The binomial distribution relies on a couple of things to be in place, otherwise we can't use it. The first thing we're relying on is basically two outcomes, and by that we would generally classify that as a success or a failure, or in some way a desired outcome and a non-desired outcome. And an example of that might be if I'm rolling a dice, I could have a desired outcome of a 5 on the dice and a non-desired outcome of anything else. That's one of the factors that must be in play. The second factor that must be in play is every success must be independent of the other, which means the probability of success for any single trial must not change. So it must be the same. So that means if I roll a dice 100 times, each time the probability of getting this desired outcome can't change from the previous or the next. That also implies that the probability of failure or of the non-desired outcome, which equals 1 minus the probability of success, will also not change. If those conditions are in place, then we can use the binomial distribution. Now, the formula we use for probability with a binomial distribution is the probability that I have a certain number of outcomes is nx p x and then q, or 1 minus p n minus x. So what this all stands for, and it seems quite bizarre right now, is first of all, this is the combination of possibilities. So I'm going to write here the number of possibilities, and we'll see what that means in a second. P is the probability of success in one trial, and 1 minus P is the probability of failure in one trial. N is the number of trials, and X is the number of successes that we want or that we are investigating. So that's all quite a big formula. Now let's see how that works, and we're going to start off looking at the number of possibilities. As I said, this part looks at the number of possibilities, and I'd like us to take our minds back to tree diagrams. If I have a tree diagram where I have a potential success or failure, and then I have another one, success, failure, and so on, there are a certain number of paths that I can take which will give me a certain number of successes and a certain number of failures. For example, if I was looking for the probability that I had 2 successes here, that means I'm looking at any path in which there are 2 P's, which means I can take this path and then add here P, P, Q. I can take P, Q, P, and I can also take Q, P, P. So that means there are 3 paths which each have 2 P's and 1 Q. And it doesn't matter in what order we have them in. This idea here, these 2 numbers in brackets, they come under the study of factorials, and they help us work out how many paths we have that have the appropriate number of successes and the appropriate number of failures. Remember as well that each success in the binomial distribution has the same probability, which means that PPQ will equal PQP, which will equal QPP. because I'm multiplying the same three numbers. So therefore here, the fact that I have three paths means in my calculations, I can calculate that this probability will be 3 times P, P, Q, whatever those probabilities are. So let's have a look at how this works, but we can already see here that I have the rest of my formula appearing. I have 2 P's because my probability of success is 2, and this will therefore be 2, and there are the 2 P's. And I have 1 Q because the probability of failure or the non-desired outcome happens once, and 3 minus 2 is 1, and there is my 1 Q, which comes from here. So really all I need to do is work out how many paths would exist on a tree diagram if I were to draw it all out. Now, as you probably realise, if we have a system where we have, for example, 10 trials or 20 trials, drawing a tree diagram is quite a sad experience. Here we've got 5 trials and already it's very messy. So let's have a look at what's happening here. This nx equals n factorial over x factorial n minus x factorial. And a factorial equals an integer multiplied by a succession of integers that are each one less. For example, 5 factorial equals 5 times 4 times 3 times 2 times 1. Remember this times 1, we probably don't need to worry about too much. 7 factorial equals 7 times 6 times 5 times 4. I think you get the idea. Therefore, nx factorial, we can set up a fraction here. And one of the nice things about factorials is we get a lot of cancelling when we enter the numbers into the equation. So let's have a look at how that works. So if I had something like n equals 7 and x equals 4, then nx would equal, remember it's n factorial over x factorial n minus x factorial, which will equal 7 factorial over 4 factorial times n minus x. 7 minus 4 is 3 factorial. Now let's write that out and let's see what we get. The numerator will be 7 times 6 times 5 times 4 times 3 times 2 times 1. And the denominator is going to be 4 times 3 times 2 times 1. And then multiplied by 3 times 2 times 1. Remember, I haven't written the times 1 because they won't make a difference. But now what happens is we get a whole lot of cancelling that we can do. We've got 4, 3 and 2 in the denominator that we can cancel with 4, 3 and 2 in the numerator. We've also got 3 times 2, which equals 6, which I can get rid of that 6 there. And the whole lot equals 35. And you can see how quickly we can have this fraction reduced down to a simple number. So that's how our formula works for the binomial distribution when we're looking for the number of successes out of a number of trials. So when we have n trials and we're looking for x successes. So in summary, the binomial distribution is something we can use only under strict circumstances. We need to have 2 outcomes or 2 possible outcomes. We could call the outcomes success or failure, or a desired outcome and a non-desired outcome. The probability of our desired outcome we call P, and therefore the probability of the non-desired outcome equals 1 minus P, and we often call that Q. So we have P and Q. The probability of our desired outcome is independent of every other trial. So that means in our system, P must stay the same in every trial. And finally, the probability of having X number of successful trials in N trials is Nx, P to the power of X, and Q to the power of N minus X. And that's basically the Nx is the number of branches in a tree diagram, P is the probability of success, X is the number of trials we want to have success or we're looking for, and N is the number of trials overall. If you found this or any of my other videos helpful, please subscribe to my channel or like the video. Thanks.